more details about it today, but some of the main reasons are to increase operational efficiency by reducing costs and waste, to respond to or reach new customers and increase competitive advantage, to protect and strengthen brand and reputation and build public trust, to build long-term business viability and success, and to respond to regulatory constraints and opportunities. So, after these initial words about today's topic that our experts later will speak about, I will share with you all a very short intro of the Utex Chamber. The European Technology Chamber is a Swiss non-profit organization in where our three main goals are competitiveness. We help and support our members to be more competitive through technology and through innovation. Sustainability, of course, we also support our members to be more sustainable, to achieve their goals being more sustainable, doing things in a more environmental friendly way. And of course, the growth and the expansion, we are helping and supporting our members also to go abroad and to establish themselves in different territories. Today's Sustainable Manufacturing Alliance, as I said before, is how to manufacture smarter and more sustainable products. Henning von Stein, chair of the Benelux Alliance, is going to moderate this great event. Jan Verhage is going to provide us a very interesting keynote speech. At the same time, he's also going to participate in the panel discussion with Ronnie Beikeland and Sasha Swint. Later, Henning will introduce them all. And at the end, I will close again this, I will participate to close this event. Now, I am going to share with you a short video about our Manufacturing Alliance. Well, this was our short video. You can also find it at our Manufacturing Alliance website. As I mentioned before, the Utex is helping and supporting many companies in different ways. We are divided into alliances, as you can see, regional alliances in where we are helping and supporting our members to have business opportunities in different territories of the world. As you can see, China, Africa, Latin America, and the DACH region in Europe are one of our main goals and activities in this way. Of course, the Benelux area is also very important for us. That's why today the Benelux Alliance is co-organizing this activity, this event. Then we have the tech alliances, and as you can see, different business sectors related to technology, like energy, like smart cities, of course, sustainable manufacturing, environment, etc. In all those alliances, in all those sectors, we have a lot of experts cooperating with us, sharing with us their knowledge, their experience, their use cases in order to improve, in order to be more competitive, in order to help each other to make European, let's say, technology going ahead and competing with the rest of regions like the USA or China. And then, of course, at the Utec, we are not only, let's say, willing to help our members to do more and better business, but also to create impact. That's why we have also our impact alliances with the SDGs, with the Women in Tech, Climate Action, etc. In there, well, basically, we are trying to help and to get visibility and to create impact in everything that we do at the Chamber. The Chamber in the Chamber, we are organizing more than 200 webinars, same as today's webinar per year, with almost 700 speakers, experts every year, also going through our events, sharing with us their knowledge, their experience. Next year, in 2023, we are going to start with our expos, hybrid events, in where many people can and will be in a physical way together with us, and all the other people that are not able to participate physically, they can do it in a virtual way. And we are having over 50,000 registrants every year. That means our network is growing every day, every year, and this is good for us, for Utec, and of course for our network and Chamber advocates. But the Chamber is really a very strong networking platform. We are arranging more than 400 networking meetings every year. In fact, next week, exactly 1 week later, we're going to make a prolongation of this webinar, speaking with some of our speakers today in a smaller group in order to get and provide this access to speakers and panelists to our members, also to some invited guests. Of course, in those networking meetings, we are also creating and providing business opportunities for our members, and then, of course, also we are providing our members information and initiation at the EU projects and fundings, tenders, grants provided by the European Union. We are also dealing with that and helping our members in this issue. Last but not least, this is our Utex ecosystem. As you can see, we have the insights, we are developing white papers, position papers, we have our magazine Visions for Europe, in where, well, our members can write articles. We have our free of charge programs like the Digital Transformation Program, the Climate Action Partnership, in where all our members can participate for free. And of course, we have our Tech.Forum, our online platform, in where our members can have their virtual booths, they can participate in our expos, they can join the user database, and almost everything that is done at the Utec is done through the Tech.Forum. And well, that's it from my side. Thank you very much for being here today. I can see a big number of people today joining us. That makes me very, very happy. Now, Henning, the microphone is yours. Have a good webinar.
Good morning, Federico. Thank you so much for this kind introduction. Good morning, dear panelists and guests, especially. Hartelijk welcome from Brussels here. I'm Henning vom Stein. I'm chairing the Benelux Alliance, and my pleasure is it to moderate this morning our dialogue here about manufacturing a smarter product, actually. And I will present to you Jan Verhagen. Jan is an electromechanical engineer and has 30 years of experience in structural composite engineering in different functions. You have been general manager of companies, and in different companies. You are since 2019 the general manager of Argesia, and you are there involved with development of thermoplastic composites. So you have different functions in Belgian associations, business associations like the European Composite Industry Association, and you will today give us the keynote about your business and about new materials which are able to, let's say, steer manufacturing towards smarter products. So, Jan, please, the floor is yours. You have to unmute yourself, please, and then yes, now we should be able to hear you.
Do you hear me now?
Yes, perfect, Jan. Go ahead.
Okay. Good morning, and thank you to Utex for inviting me as a keynote speaker. So let me see if this works. Okay, the main topic of this seminar is how to manufacture smarter and more sustainable products. But I spend a lot of my career in manufacturing new products, introducing new products, and the key is always designing these products so in such a way that manufacturing of smarter and more sustainable products is possible. So, and I'm aiming the last 4 or 5 years on structural thermoplastic composites. So I have to give you this disclaimer. This is a personal view, not as a function of all my memberships. And it is based on new insights over the last 4 years with Agesia and on my 30 years experience as a structural composites engineer. So Agesia is based in Lokeren. It was founded in end 18, early 19, and we do engineering, testing, certification, and production technology for dynamic loaded thermoplastic composite structures. Agesia is embedded in a bigger entity, the Rover Industries, who provides me all the soft hardware and further studies around IoT and so on. So we solve problems in steel structure by replacing steel through thermoplastic composites, structural thermoplastic composites, there where steel did not provide a solution for the customer. So our technology is based on 4 pillars: new materials, new technology. We do a lot of digitalization of our development. We never develop something. We always need an application brought to us by a customer, and we constantly have an eye on the circular economy. Yeah. So this is a scheme of how we work. Do I have a pointer? Yes. So we always start with the problem. We design in 3D a complete CAD model, and then we start using finite element analysis to have a first idea of how the product will work really in nature. Then we do coupon testing of the material we will use. We do scale testing, and then final testing on our own test bench in real dimensions. And then we go to use it is in the first time on our test bench, and eventually we go back and we do that until we are satisfied. And then this circle is done in nature, and all over this process we monitor our data with optical fibers, and I come back to that later. So we based our technology on my former development. Back in 2000, I developed a stitched panel, which was very strong, called Acrosoma. And this was completely in Thermoset. And we now developed a new panel completely in thermoplastic material. We use as face the Neomera organo sheets from Johns Manville, which is a very exciting product. We use recycled PET foam, so that's a very good item for the circular economy. And we connect both the sheets to the foam with our new developed Covalent intermediate bonding system. This is a very good patented system where we have a chemical bonding between the PA6 molecules and the PET molecules. So they're connected chemically. And we have also a patent on connecting these nylon face sheets to metal. So for those who want to know why I changed my brains from Thermoset to Thermoplastics, there's a very nice presentation on my website, arhesia.com, where I explained already in 2020 why I made this shift. So very shortly, for those who do not know the difference between Thermoset and Thermoplast, if you take an egg, you can make a fried egg of it, but you cannot transform it back either to another egg or to an omelette. If you take a glass of water, you can make ice cubes of this. These ice cubes can be transformed again to a glass of water or to bigger ice cubes. This gives an enormous advantage in the circular economy for the reuse or even upgrade the material that we make in the future. So very, very quickly, the thermoplastic composite market, 20 years ago, it was not possible yet to make dynamic loaded structures, heavily loaded structures in thermoplastic composites. Back in the 2010s and further, this is a growing market. And if you see the share of the market of thermoplastic composites is growing and still growing. If you look to the share of thermoplastic composites by application, you can see that transport is the biggest part. And but with transport, most people mention aerospace, passenger cars, but our mission is to expand this to heavy transportation equipment, which is still a blank sheet of paper in composites all over. So when is replacing steel by thermoplastic composites an option, the customer must trust new materials. And over the last 30 years, my mission has always been convince the traditional steel engineers. And even today, you have a lot of steel engineers managing engineering offices who are still obstructing using composites in their material. If a major problem for the customer cannot be solved with steel, so for example, significant increase of load capacity, weight and volume in equipment, which leads to less trucks on the road, less trains on the rails, which is good for the environment. And always keep an eye on an affordable market price. Nobody wants to pay for a better product with more technical values if the price is too expensive and the risk is too high. We need a proof of circularity. My experience is that how much is the customer ready to pay for a more sustainable product? This is still a long, long way to go. We have, however, a growing awareness and acceptance for circular economy that I can feel, but it is absolutely necessary that the legal frame is increased, because this is, to my opinion, the only way that circular economy will find its place. So if you replace steel by composites and you have a basic price of €2 per kilo for steel and you replace it by 8 kilo, then it needs one quarter or ending in 1/4 of the original weight. To my experience, you can only achieve 2/3. That means that design with new materials must decrease significant the manufacturing cost. So that's the key point for engineering with thermoplastic or with composites as a whole. So, this should be a video, but you cannot see it. Well, I'm sorry.
This is no matter, Jan, because we should come to an end of the presentation and join the discussion soon. So perhaps you go ahead with the last slides.
But what is important is we achieved a perfect digital twin by monitoring our products with optical fibers and string gauges, and connected immediately to our FAE model, and so improving the quality of it. So We use PET foam. It's completely recycled PET bottle foam. And we have proven the circularity of our material combining two TPCs. It's very difficult to separate. CETIM found a way to do it, and we have an application in the furniture industry for our product. But this is one proof of the circularity. At the end of life, which will be in 10 to 20 years, where I will be walking around with a rollator probably. So new and more efficient technology, I am absolutely sure, will be developed in the coming decades. So I had an animation for this, but my thesis in '78 was about the study about wind energy. So at that time, there were only 2 wind turbines in the world, less than 1 megawatt. So in '78, that's 44 years ago. And we came to the conclusion that at that moment in our economical study, that wind energy was absolutely financial, not viable. But this was in '78. With the technology knowledge of '78, we made a prediction. Composite blades came 20 years after. In the beginning, they were all aluminum blades. So, and in '78, we had no computers, no cell phones, no finite elements. Nobody talked about circular economy. So this was a complete other frame where we made our study. And it's important to mention that because a lot of predictions are made on assumptions of today and yesterday without really thinking on what could be done in the future. So UCI and also ACMA in America pretend or are sure that composites will be fully circular in 2050, which is 28 years from now. These are assumptions based on what we know today. We can guess, but certainly are not sure what technologies will have emerged in the next decades. But we trust that new technologies in the coming decades will solve the problem of today. And that's what Ahesia is working on. So I always say work with the experiences of yesterday, with the technology available today, and with a close look on new technologies of tomorrow. So when I started my career on the left side, we all had engineering offices with 50 to 100 engineers working on drawing boards. And the data transfer was made on paper. So then early 80s, the XP came up with some already very basic CAD programs. And the transfer was still made by hand, by a floppy disk, or even a CD later on. If you see the engineering office of Ahesia today, every engineer has a lot of data, the best computers, best data transfer, but it's still made on cable or with CD. And what we believe, or what we are working on, we will gather data from our equipments on rail and road by IoT. So this is something we are working on. What is emerging now is the artificial intelligence. And if you look to the bar underneath, up to now, the human factor has always been very important. It has been made easy by the machines, but it has not been overruled by the machine. If you look to the artificial intelligence, it may be possible that it is overruled by the machine. So from Google, I learned that by 2050, an artificial intelligence will be 1 billion times more intelligent than a human being in everything. So that is very scary. So recently, I attended.
We need to come to an end, John.
Yeah, but 2 slides.
Okay.
So recently, I attended the Jones Manville Academy, where FMG presented a very scary theory about how the future of artificial intelligence will look like. And if you look to the right-hand side, this is very scary of what the computer will be able to do. Hold on, I will hurry up. So the soup, what my opinion is, after 40 years experience, the soup will never be eaten as hot as it is served. Turning a tanker is not easy, and it will not be easy also in SMEs and the basic engineering when you look to artificial intelligence and what we do today. So we have a mission, Ahesia. I think personally that the artificial intelligence introduction in SME engineering offices, I'm not talking about the big guys, will grow slower than what is predicted. The machines will be available, but probably not be used as much as we think. We started already with a predictive digital twin, and that is where we are now. We are going to use artificial intelligence to do a predictive digital twin. So, and thank you for your attention.
And thank you so much, Jan, for that presentation. And it's so important to see how decisive it is to share experience. And what you said, what can be or what could be done in future needs to be decided today. And I think that is what the EU Tech Chamber and the European Senate is all about. So my pleasure is it also to have Sascha Schwind and Ronny Bakeland with us on the panel. Sascha Schwind is Managing Director at Nanopool, a family business occupied with producing ultra-thin multifunctional barrier layers. So this is pretty much a, if I'm right, a combination with other materials on the surface. So you are a specialist on the surfaces of materials, and you have been active also at international level as a young entrepreneurs G20 summit in Sydney. You were representing Germany, Sascha, and you are since 2021, you are a senator of the European Senate, the partner organization of the EU Tech Chamber. And thank you for being with us today. And now it comes to Ronny Bakeland, my good old friend here from the Benelux region, from Belgium. We were together when you have been managing director at ThyssenKrupp here in the country, and you are since have been active in diverse companies, especially concentrating on restructuring businesses, which is pretty much important in these times of today in building up new business models. So please, dear guests, if you have any questions, go already to the public chat and start now with sending us the questions. I will take care of that later. But I wanted to start with you, Ronny, and on a point Jan mentioned at the end. Why is big data actually and AI so important to leverage, or let's say develop advanced manufacturing and engineering? Why is that so important, Ronny?
Thank you very much for the question, Henning. First of all, I want to say something. I saw that one participant, Clément Hill, is a world-known expert on composites, working in US at NASA, and I think he was up this morning at 3 o'clock. So welcome, Clément.
Thank you for being with us, Clément. Thank you so much, and thank you for informing us all. Thank you so much, Ronny.
Yeah. Secondly, about your question, I think that AI, quantum computing, and the cloud are transcendental or transversal technologies. And if you look at the latest report of McKinsey end of September about the competitiveness of Europe, you see that we have an advantage or status quo in two technologies, which is new materials and next level automation. There will be a book coming out very soon, The Titanium Economy. I'm not promoting McKinsey here, but just to let us know how current all these evolutions are. And I think that if you look at Jan's presentation and his development and his acceleration through the cloud, through artificial, normally this is given us algorithms and fast computing and data. Otherwise, we cannot accelerate and to become the number one.
I see that we had that in other webinars also. The point that big data is about experience and artificial intelligence is more about experimenting with and learning quicker about the materials. Sasha, if I may address the question to you and Nanopool, it is about, you have the issue of bringing your product to different materials, actually. So matching your product and at the surfaces and your experience for the surfaces to different products. How, when you see Jan's presentation and the time it took, for example, from switching from one material to the other, and whatever new materials coming up and also in production and having different characteristics, how do you manage this variety of applications? How is that possible to adapt to such kind of an environment, Sasha?
Thank you for that question, Henning, and thank you for the presentation, Jan. Can you hear me? Okay. So we are now 20 years. We are existing since 20 years as a family business, and being aware from the research and development to the ready-to-use products, we have all the time the need to match the needed functionalities with our product metrics. What we do is we add layers of SiO2 to many different surfaces, and we have to understand the technical needs from the business partner. And we use also data, big data, we use customer experiences, and we use big data for the product development. Very, very important. We do apply our technology, which is layer of SiO2, which is lesser than 100 nanometer. The layer is very stretchable, it does not break, and it's abrasive resistant. And it gives functionalities such as hydrophobicity, oleophobia, germ repellents, anti-algae properties, antimicrobial properties, and all that. And this needs to be matched with the material of the customer. What we bring to the customer, what we bring to already smart material, we make the material smarter. It means lesser cleaning efforts, lesser chemical agents, and lesser material loss and better functionality. Significantly, we save the cost for the maintenance, and we reducing by that the CO2 footprint. So that is not only working on products, it's also working on machines, on conveyor belts, on equipment. It keeps the surface much longer in life in production, makes it more efficiently and with less downtime.
So surface, that is also a life period issue for products, making products more resistant to whatever attacks from the outside. And can you explain also where the factor of AI and big data is coming into that issue? Is that learning process already arriving in your company from making your product matching to other materials? Does data and AI play a role here?
Definitely. It goes also into the product development. We use predictive models for new products and services, key attributes of the future needs of our business partners and of industries. And for us, it's very important the customer experience. And so a clear view of the customer experience and the possibilities we can match for future products. And all that goes together also with matchmaking platforms. So platform is a very important tool. Platforms are very important tools to bring technologies together to business partners and markets and segments and technology hubs. So these play a very vital role in our company activities, also since a long time.
Thank you so much, Jascha. And Jan, may I play this to you, given this new field of matching advanced materials and new materials coming in. You described that process since the 78 and making predictions already at the time, switching on your path of experience from one material to the other. What can you say about the speed of that process? Is that accelerating today because of the matching of different fields of technologies coming together, served by new instruments like data and AI? Is that, in your experience, because you said, okay, we have to predict, okay? Utex Chamber is all about giving better orientation. So if speed is high, we need to match our minds even better. So that is the issue. Can you say something about the speed of today and whatever? Will we switch more quickly from one material to the other because the connections with experience like Jascha is possible today?
Well, let me go back to 1996 when I started with my first all composite trailer. We needed to have 250,000 up to 500,000 kilometers on the road, and then do a visual inspection on everything, and then start again on the drawing board. Right now, what we are doing is we introduce these new materials, but we also introduce tools for gathering this data very quickly. So what took me 1 to 2 years in the past to discover, we do it now in 14 days. We have a test bench that we monitor with optical fibers. The big problem is not that we gather this data. The big problem is how to process these data very quickly, analyze, and take the right conclusions. And that is still the factor that takes the most time. Introducing new materials is easy. You just do it, but if it is going to work, that's another story.
Ronnie, at that point, the question about metals and minerals, you have done a lot of experience, let's say, with different materials and steel products. And Jan also mentioned steel might be replaced by different developments. So what does that mean for, let's say, renewable tech units will replace fossil fuel components? So what does that mean for the environment and our, let's say, resources on the one hand, and emissions, CO2 on the other hand? Do you have an idea about that, Ronnie?
First of all, we have two expert scientists, Vaclav Schmil and Simon Michaud in Canada. The latter said that there is not enough materials in the ground to be mined in 1 decade. So we have to rely on new materials to substitute other materials where we have not enough. That is one option, and I think we have to do it. But Jan told me last week that the problem is always that we don't know what we don't know yet. So we take these decisions on information we don't have today. So I think that we have to do a lot to scale up a company as Agesia. And that's where I believe in the triple helix model, which is in essence a communication model, to promote a company, somebody like Jan and Clément Hill. They are inventors, they are owners, but they need help, and that's where government, education, universities, and have to come together. And also the geopolitical question. If you look at Belgium, Benelux, and Germany, so North and Westphalen, we have the #1 chemical hub in the world. You have one of the best universities. As I said, McKinsey said that we are #1 in materials, advanced materials. So I think we have to provide financial accelerators to companies, to startup companies as Agesia and Nanopole. And this is where there is something in Europe that I think we have to look at.
Okay, thank you, Ronnie, about that combination university, industry, government. Sasha, is that when it comes to coating, you said about healthcare issues, about easier to handle surfaces, surface as a barrier, right? So to make also products more sustainable. So the circular economy argument comes in here, also with regard to packaging. What exactly does that mean? Could you explain that again? And if that is, for example, also accelerated by the combination of university, research, industry, and government, please address also the issue of regulation here, Sasha.
Thank you for the question, Henning. So yes, so we talked here about materials, and I just took the example of having the example with packaging, where we have the experience that a lot of plastic is out there. And many years ago, we started a project of having a barrier layer for paper-based packaging. Here, packagings which are on the market now with our technology on. We are in supermarkets now. These are the first packagings made of paper without having any additional plastics in. So that's really a milestone. But how we came to that, research development with our team, with universities, with institutes, convincing customers, bringing the customer to that step that he's able to do that in their industrial process. And that matters. So an idea is important, but you have to bring the idea into the production line, and in order to make it available to the people to participate from that, in order to save unwanted substances. And we are now based on that framework. One important aspect has been in that framework the European regulation, so the European SUP regulation, which is regulating the single-use plastic objects. So, and we were just targeting into that space with our technology, because we not having plastic in our products. We have a barrier layer which works as plastic, and we can substitute many other chemicals now in that field. And what matters is really to bring all that together. The research, development, the product, and the political framework has to be there, and the customer needs in that way the production company. And I have to say, the first mover in that field has been a Belgium-based production packaging specialist company. They were saying, okay, we trust in that. We saw all the certificates, we saw the capabilities. We do it now in the pilot on our machines, and we have overcome that hurdle. We are now working with them and with others to bring the technology into the packaging market.
Very impressive issue here about, using different materials by adding very future-oriented surfaces here. Jan, may I address two questions of the public chat here to you? By Seoni Ro, you are talking about new materials for the moment. Okay, that is your shift from thermoplastics to Thermoset. from Thermoset to Thermoplast. But how about to reuse and recycle those materials after end of use? Is the recycling better than the steel materials? It's 100%. Steel is 100% recyclable. But Irene also asked. Also, there is an aspect to consider about recycling composite materials, which at the moment is rather complicated. Jan, may you explain and taking care of that?
I can point out to the documents UCI, the European Composites Industry Association, will publish in the coming weeks about recycling of composites, mainly thermoset, which is still 85 to 90% of the composite market. There's a big confidence that all this will be possible. Now, there's a big difference between recycling, reuse, upcycling, downcycling. These are all words where we try to give a definition on now. Now, circular economy principle is that you take your product after end of life and you transfer it to even a better product, the same product, or a little bit downsized. So this is possible, already proven with thermoplastic composites, where they are grinded and used in overmolding for example, battery cases for the automotive industry. The way for thermoset and composites to recycle or reuse is the cement kiln route, where thermosets are used to upgrade the cement production and make it more sustainable. Saying this, nearly every university in the world and every organization is working on the reuse or circular use of thermoset composites. But as I said, it's still a long way. We're not there yet, but it is possible. Now, saying this, metal is already in use industrially for 300 to 400 years. So the ways to find a reuse of that material are already centuries old. Composites are not 100 years old, so I would say give it a break and we will come to a solution.
Great insight. Thank you so much, Jan. May I come to the third aspect of our title of the webinar today? I think we have a good feeling about smarter and sustainable products. And now let me come to the issue of manufacturing. If we see in the last, I think, 10 minutes, we have Federico, or 8 minutes. How many minutes left, Federico?
Well, you still have. I only need 2 minutes, so let's say you have 8 minutes still.
Great. So let's address the rest of that, because that is, I think it's about manufacturing itself, and we have been concentrating on the products. So recycling and circular economy, the products, AI with regard to smarter and data and sustainable products. But now when it comes to manufacturing, what can you say? Jan, you mentioned that if, for example, replacing steel, I think the European Union is all about coal and steel, a very, very important material for the building up the European Union. But if you replace that now by composites, does this mean completely new manufacturing plants also, or what does it mean even for value chains for the production processes themselves?
Well, first of all, I do not believe anymore in replacing complete structures by composite. There will always be a place for composites in combination with metal in the high-loaded structures as I am working in. Saying this, that means that components will be taken out of the existing construction, combined to have a lower manufacturing cost, but integrated in existing production lines. It's not like you need to build a complete new factory for that. you need to adapt the production line to introduce composite components. And these components can be made in separate factories or production halls. But the mistake is that in the beginning I did that, replacing all the steel by composites. And composites have also disadvantages that cannot be solved and where you need steel.
Great. So it's all about combining things, Sasha, right? It's like your issue, combining your technology with what you have shown, paper, for example, making packaging totally different. Can you see that in the packaging world already? Does this also come into the manufacturing of packaging materials? These characteristics of that new combinations coming in, does this change in your experience? Does this change production itself? You have to unmute, please, Sasha. Your mic.
Okay, I'm sorry. Now you should hear me. Yes, it changed the production already in a positive way because it's very it saves energy during the production, because if you put an PE layer on top, just for example, it's much more energy and CO2 needed, and then the simple application of the technology we have. It's also comes into the field if you have just another example, the energy production. You have existing panels on rooftops, you have isolators, they are there, and we just can improve that. So we can improve the production capacity by making them multifunctional. Yes, there's a significant impact on the production, and also of the production of products, of energy, and so on already.
Very quick question to this also. Does this mean something for value chains around the globe? Is because different regions might advance in a different pace. Does this mean also that production itself will come more regional, will go local again?
Yes, that belongs to our model, definitely. We should be able to have a local production on every continent, in every area. Importantly, to save also transport, to save costs, to save CO2, and to make these existing industries more profitable. If you just look at the background, I just showed a slide on a PV panel in the desert, it doesn't speak, sand doesn't speak, so there is a significant more output of energy if the sun comes directly to the PV panel than if it's just covered with sand. And that's the technology everybody should have in his system, we believe. To create many different value chains.
Okay, thank you. But there's also something about trade and global value production, value chains and supply chains. Yeah. Ronnie, may I come to the old proudness of the steel industry? The material is 100% recyclable. Sihoni asked that question again in public chat. But even steel materials with different compositions have also very complicated processes for reuse and recycling. That will be the cost issue. In your experience in different companies, different materials, also in commercializing them, what is your answer to this?
Well, first of all, you have every modern society, if you talk about urbanization, needs 4 pillars, which is steel, cement, plastics, and ammonia to feed people. Now, if you look at ammonia, there is a biorevolution of microbes. It's completely new. I hope development will be very fast. If you look at plastics, we are talking today, or composites, excuse me for my ignorance. And then thirdly, you have cement, a lot of it is done with the zeolite market. And if I go to your question about steel, well, steel is one of the most energy demanding material, and there I think there is a lot that is being done about with hydrogen and reducing energy requirements to produce steel, but we are talking about materials going into the EV revolution. We have to look at the applications, and if we make, for example, I give you an example, somebody of 50 kilo driving an SUV of 5 tons, this is not normal. So if we replace the steel with composites, then Jan can tell you another story.
One of my favorites one of my favorites you just mentioned, that is, it does not make sense if you're driving with these products. So I think if we have these materials, we have also to develop, and that the design is coming in, designing completely new, let's say, applications, as you say, Ronnie. Jan, Sasha, Ronnie, and thank you so much for that panel today. It was a pleasure moderating it. Please, Jan, if you can share, because there are some questions in the public chat, if you could share your slides on your company website, that would be great. I'm looking forward in working with you in the Benelux Alliance on these issues we just elaborated today. And thank you so much for joining, and Federico for hosting us with you and the topic. And I hand over back to you, Federico.
Thank you so much, Henning, and thank you all for joining us today. We hope that all of you enjoyed the webinar, same as I did. Special thanks, of course, to our 3 great panelists, Jan, Sasha, Ronnie, also Henning for moderating so well. Really amazing sharing the panel with you all. Now, I am going to provide you a little present in the name of the Utex. As you may know, one of our main goals is sustainability, and we always provide to all our speakers a tree certificate. That means we are planting a tree in Africa in your name in order to help with the reduction of CO2 emissions. So, well, for those of you that doesn't have your screen on, please, again, switch on your screen, because I am sharing the tree certificates right now. So this is a tree certificate for Jan Verhage, another tree certificate for Ronnie Bijkeland, and last but not least, a tree certificate, of course, for Sasha Schwind. Thank you so much for joining us today. Thank you so much for sharing your knowledge and your experience and your use cases with us and with our audience. And really an honor to share the panel today with you all. Thank you also to our audience again for joining us today. Please join us at our LinkedIn Manufacturing Alliance group. We hope to see you soon at our next events. And as always, remember, technology obliges. Thank you and goodbye.
Thank you all. Have a good day. Thank you and see you soon.
Bye. Thank you. Bye.
You are currently the only person in this conference.